forces, and equilibrium. But today we'll be looking at contact force, otherwise known as friction. Contact force, otherwise known as friction. So the concept of resolution and the idea of equilibrium will still be applied here. Is that clear?
Yes, sir.
So I want you to, as a recap, I want you to give me the two major types of frictional force. Abolaji, give me one. Then Ibukun will give me the other one. You have forgotten.
Limiting frictional force, I'm not sure.
Limiting. Good morning, Mr. Jason. Ibukun, do you agree with that?
No, sir.
No. Okay. So which one can you remember?
That's static friction.
Very good. And
Dynamic friction.
dynamic friction. Abolaji, go and take your P4. Go and take your P4 and begin to read again. Static and dynamic friction. And what's the difference between them? Jason, what's the difference between static and dynamic friction? Mr. Jason,
Sir?
what is the difference between static and dynamic friction?
I can't remember.
Abolaji, the difference between static and dynamic friction.
I can't remember too.
You guys need spanking. Ibukun, can you help again?
Static friction is when the object is at rest.
Okay.
Oh, and then dynamic friction is when object is moving
Or about.
about.
Very good. And somebody mentioned limiting friction the other time. I think Bolaji, you mentioned limiting friction.
Yes.
Yeah, that's where the limiting friction comes in. And basically, you can distinguish them by this expression. F equals mu NR. Dynamic friction. F less or equal to mu NR. Static friction. So I believe you still remember that. Let me use FR to denote frictional force, mu coefficient of friction, NR normal reaction. So take note of this. The reason why you must take note of this is if questions say find the static friction, it's just the way you express it. It's not going to affect the values, but you can be penalized if you use equal to where you're expected to use less than or equal to. So take note of that. Am I communicating?
Yes, sir.
Okay. Now, another important thing that you still need to remember that I'm going to ask you now is, what's the major importance of friction? Or what does friction do?
Maybe it opposes motion.
Maybe. You are not affirmative. Maybe. Okay? Maybe. Maybe it opposes motion. Or you are saying categorically that it opposes motion.
But I'm not sure if for what I'm not sure if it's correct for
That's the major work. It opposes motion. It opposes motion. And that is why if you keep an object in a rough surface, that is why the object will remain there, because the surface is rough. So there is a force that is opposing it. So you can have it either in horizontal plane, or in an inclined plane, or in a vertical plane. When I say vertical plane now or horizontal plane, it can happen in a rod. Is that clear?
yes. Sir.
So let's see example to drive home this point. But in that example, I will allow you to do some of the things there based on your knowledge of resolution of forces. Make sure you draw your own perfectly. I'm changing the color there to show that there is a ring. So draw that diagram. When you're done, let me know so that I can dictate the question.
I'm done.
Okay, let's wait for others.
Also done.
Okay, let's wait for Jason.
I'm done.
Okay, so write the question now. A small ring of mass 0.6 kilogram. A small ring of mass 0.6 kilogram is threaded on a rough rod which is fixed vertically. Is threaded on a rough rod which is fixed vertically. Full stop. The ring is in equilibrium. The ring is in equilibrium. Comma. acted on by a force of magnitude 5 Newton, pulling upwards at 30 degrees to the vertical. The ring is in equilibrium, acted on by a force of magnitude 5 Newton, pulling upwards at 30 degrees to the vertical. Full stop. Question A. Find the frictional force acting on the ring. Find the frictional force acting on the ring. Question B. The ring is on the point of sliding down the rod. The ring is on the point of sliding down the rod. Full stop. Find the coefficient. Find the coefficient of friction. Between the ring and the rod. Find the coefficient of friction between the ring and the rod. So the first thing we are going to do is to flesh up this diagram. But before that, let me just show you a number of things there. Then I will now transfer it to the other side. Now, the vertical, let's take this as our y-axis. Then at this point here, let's take this as our x-axis. Is that clear?
Yes, sir.
So, in friction that you have been explained to before, the normal reaction and the frictional force, what are they to one another?
They are perpendicular to one another.
Very good. They are perpendicular to one another. So I'm going to indicate that now. So let me just transfer that to this side. So the position where the ring is, let me just call it dot. This is the force of 5 Newton. The 5 Newton force is here. Now, the ring placed in a vertical rod. In which position or in which direction will it move? If that ring is stationary on that rod, what is keeping it stationary? It's obvious that it's the 5 Newton force, isn't it?
Yes, sir.
So that means it has tendency, or you want to say that the weight of the rod we act vertically downwards. So the weight will be here, mg. Then, as we have said the other time that frictional force opposes motion, the frictional force will act vertically upward. And because we already know that frictional force and normal reaction are perpendicular to each other, so the normal reaction will be here. Hope I'm communicating. So the angle between the frictional force and the 5 Newton is what we have as 30 degrees, as shown in the diagram here. So the frictional force, the weight, they are acting parallel to the rod. So this is what we have. This is the first thing you must do. And this is where you pick it up from. Hope I'm communicating. Yes. So you can see where resolution of forces comes in now. To answer the first question, the frictional force, in which direction am I going to resolve all the forces? In which direction? To answer question A, I want to find, okay, let me allow you draw this before I stroll up so that I can do other things. But before you draw, hold on. Don't forget, I've told you, in resolution of forces, always target the angle the force is making with the horizontal. From the question, we have been given the angle it makes with the vertical. So you need to find the angle it makes with the horizontal. In this sense, it will be what? 90 minus 30, 60 degrees. So the angle the 5 Newton force is making with the horizontal will be what? 60 degrees. And of course, NR and FR, they are perpendicular. So this place is 90. Then the NR is also perpendicular to the weight. So we are good to go. Please draw this. When you are done that drawing, let me know so that we can proceed. So can I move on?
Yes, sir.
Now, if you look at the frictional force, we have it vertically upwards. The 5 Newton force has tendency to act either horizontally or vertically. So because I want to determine the frictional force according to question A, so it's advisable I resolve vertically. So the vertical component will now be FR sine 90, because it's making 90 degrees to the horizontal, plus 5 sine 60 because 5 Newton is making 60 degrees to the horizontal, minus mg sine 90, because that's also making 90 degrees to the horizontal, equals 0. Why am I equating it to 0?
What is that equilibrium?
Yes, because the question says the system is at equilibrium. The ring is at equilibrium. So reason for equating it to 0. So sine 90 is 1. So this will become FR plus 5 times sine 60. Sine 60 sine 60 will be what? In exact form or in decimal, whichever way you want it. Since the question is not saying we should find the exact. Is that clear?
0.8660.
0.8660 minus mg, because sine 90 is also 1, equals 0. So that means FR equals mg minus, which is closer to where people are talking. Maybe you should mute your mic. Minus 5 times 0.8660. So let's substitute the value of m. And if, of course, you know that for these mechanics, we take G to be 10, not 9.8 here. So the mass given to us, 0.6 times 10 minus 5 times 0.8660. So if you multiply that correctly, you will get 6 minus 4.33, and that will give us 1.67 to 3 significant figure, which is the standard in this course. So 1.67 Newton. That's the frictional force. Any question? Okay.
Sir, please, I have a question.
Okay, what's the question?
Sir, we are taking that.
You are where there is noise. Why don't you move away from that place? Go inside the house.
So we are assuming that the ring is moving downwards.
No. We are not assuming. We are factual. The rod is vertical. By standard, the weight will act downwards. It's not an assumption. It's fact. Do you understand? As you are seated, in which direction is your weight acting?
Downwards.
Downwards. So that's it. If the 5 Newton force is not there, the ring will not be able to stay, no matter how rough the rod is. Do you get that?
Yes.
Because force of gravity will be so much influential on it. When you're done writing that, let me know.
So I'm done.
Let's wait for... Ibukun, are you done?
Yes, sir, I'm done.
Okay. So let's do the B part. The B part says we should find the coefficient of friction. So let's resolve horizontally now. So why are we taking horizontal component now? So that we can deal with the normal reaction. So let's resolve them vertically, horizontally. Now, by standard, you can see that I did not deal with the horizontal, the NR, because it has horizontal component already. Do you understand that?
Yes, sir.
While I'm doing A, that's what I mean. So let's resolve horizontally now. If you want to take MG and FR into consideration while you are taking horizontal component, no problem. It will still go to 0. But me, I like putting it there so that by the time you are revisiting your notes, you know why they are not there in the next line. So let's take horizontal component. If you had considered NR here, NR is parallel to x-axis. So it will have been sine 0, NR sine 0. Hope you know that. And sine 0 is 0, so it will go off. So let's start with the FR. FR cos 90 plus, we are resolving the 5 Newton to the positive x-axis. So plus 5 cos 60. Remember, in resolution, the angle we have used, either in vertical or horizontal, the same angle you use when you are doing the other one. Then let's go to mg plus mg cos 90, because it's also perpendicular to the x-axis, minus nr. nr is a negative x-axis. So nr cos 0, because it's parallel to x-axis. And because the system is in equilibrium, everything equals 0. Now, cos 90 is 0. This will go. Cos 90 is 0. This will go. So we will be left with 5 cos 60 minus nr, because cos 0 is 1 equals 0. So nr will be 5 cos 60. So press your calculator for that. 5 cos 60.
2.5.
2.5. So that means the normal reaction force is 2.5 Newton. Now, I'm looking for coefficient of friction. Remember, for dynamic friction, we said Fr equals mu Nr. So frictional force in A has been determined to be 1.67 equals mu times 2.5. So mu will now be 1.67 divided by 2.5. That will give us 0.668. What will be the unit?
There's no unit.
Why?
Because Newton will cancel out it.
Clap yourself. That's good. There's no unit for coefficient of friction because they have cancelled out. Frictional force is in Newton, normal reaction is in Newton, so they will cancel out each other. So it's a dimensionless parameter. So copy that quickly.
Done.
Okay. Let's read for that.
So I'm done. I'm almost said that.
Okay. So let me give you this one to play around with. Try the diagram.
Done.
Okay.
I almost said that.
Okay.
So I'm done.
All right. So please pencil down this question. Two light strings are attached to a block of mass 20 kilogram. Two light strings are attached to a block of mass 20 kilogram. Full stop. The block is in equilibrium on a horizontal surface AB. Two light strings are attached to a block of mass 20 kilogram. Full stop. The block is in equilibrium on a horizontal surface AB with the strings taut. With the strings taut. Full stop. The strings make angles of 60° and 30° with the horizontal. The strings make angles of 60° and 30° with the horizontal on either side of the block. On either side of the block. Full stop. The tensions in the strings. The tensions in the strings are T Newton and 75 Newton respectively. T Newton and 75 Newton respectively. Full stop. Question A. Question A. Given that the surface is smooth, given that the surface is smooth, comma, find the values, no, find the value of T and the magnitude of the contact force acting on the block. Find the value of T and the magnitude of the contact force acting on the block. Full stop. That's question A. Are you ready to take question B?
Yes, sir. Yes.
Question B. It is given instead that the surface is rough. It is given instead that the surface is rough and that the block is on the point of slipping. Is on the point of slipping. Full stop. The frictional force on the block has magnitude 25 Newton and acts towards A. And acts towards A. Full stop. Find the coefficient of friction between the block and the surface. Find the coefficient of friction between the block and the surface. Full stop. So let me allow you to do that. I imagine. Bó ṣe lè má ti bọ̀ mí sí. Hope you guys are making progress.
Yes, sir.
So what have you found so far?
So I found T tension
Okay. What did you get?
187.64.
187. Iboko, is that what you obtained too?
So I got 130. I got 130.
130 is correct. Or 129.9.
Yes. Yes.
So JC, what happened? In which direction did you resolve?
Vertically.
No. You don't need to resolve vertically to get that.
I think I just saw my mistake.
Okay. You know, you can bring this down to this, the weight down here. (75 Newton) acting at 30°. Then T T acting at 60°. So this is what we are supposed to have. So to get T, resolving horizontally is sufficient. Is that clear?
Yes, sir.
So there are two questions in A. T and the magnitude of the contact force. So for those of you that have obtained correct value, what is your contact force?
200 meters.
No. What is contact force in that sense? Normal reaction.
Yes, normal reaction.
So what did you say you get? What do you say you get?
Then 200
No.
back.
No. Ibukun, what do you get?
I've not got things.
Where will the normal reaction from this diagram? The normal reaction will be here.
Yes, sir. In Newtons.
50 Newton is correct. That's correct. So proceed to question B. Now, don't forget in question B that friction is to be considered now. And as a matter of fact, you have been given the value of the frictional force. So it's now up to you to show the direction in which the frictional force is acting. And I think the question is straightforward. You have been given the direction in which it is acting. So that means it will be opposing which of the forces?
0.5 Newton.
The what?
0.5 Newton force.
Very good. Very good. So that means you need to add to that diagram the frictional force. It should be true by now. Jason, have you corrected question A?
Yes, sir.
Okay. So have you gotten tension for B?
Tension for
Question B.
um 80 newtons.
Very good. Ibukun, is that what you obtained too? Ibukun? Is Ibukun not there again?
So that's what I got to.
Okay. Jason, what about you?
So I'm still solving it.
Why is it taking you that long? Just resolve horizontally. Just resolve these forces horizontally. For instance, don't forget you've been told that the system is in equilibrium. So just get the horizontal component. Fr
So
minus Fr minus T cos 60, then plus 75 cos 30 equals 0 because we are told it's in equilibrium. So that settles it.
I've gotten the answer.
Uh-huh. So 79.9 or 80 is acceptable.
Yes, sir.
Okay? Have you found the normal reaction?
Yes.
So what do you get?
95.
No, that's too far. Ibukun,
So 93.
who is talking? Ibukun?
Jason.
Jason, okay, what do you say you get?
93.
On the dot, you should be point
No,
something.
93.30.
Very good. 93.3. 93.3. Abolaji, that's what you're supposed to get. Check your work.
Okay.
93.3, not 95. To get that, you need vertical components. You can see that NR is acting vertically upwards. So you need to get vertical components. You can say NR.
Yeah, I think I'm mistake.
Please always be conscious.
The coefficient of friction is 0.857.
0 point, 0 point what?
It's
No,
0.857.
no. Look at it very well.
0.268.
Very good. 0.268. Correct. So if you could look at what you have done very well. You know you have been given frictional force. So Fr equals mu Nr. So mu will be Fr over Nr. And that's 25 over what? 93? 93.3. Why don't you use the 4 digits? Let me check with my calculator. If using this will not. Where do you see 25 from? Are you sure your calculator is working well? Ibukun, check your calculator again. With what you have given me, this is what I obtained.
So I've seen it, I've got it. There is another fictional code I use.
You not use 25.
Yeah.
Abolaji, are you true?
Yes, sir.
Okay. So that's a convenient point for us to stop today. So we'll continue from there in our next meeting.
All right.
So thanks for joining.